Hello everybody! We are here today to talk about the rendering script. Do you know why are we talking about the rendering script? Because you asked that. We suggested to propose the topics for the next video and you suggested we speak about the rendering script, and that's what we're doing today. We, as in me, again me, but we have a new person in the room.
Yes, me, Sven.
Sven.
Yes.
Great, Sven. So Sven, we are covering the basics of the rendering script.
Yes.
And we'll try to outline the post effects of it, as in how do you do the post effect on the full screen and maybe on the part of the screen.
Yeah.
But let's start exploring what is the custom render script.
In Defold, you have a couple of different script types. You have the game object script type, you have the GUI scripts, and you also have the render scripts. And render scripts is pretty much like the other scripts. You have a init function, you have a update function that runs every frame over here. You also can specify a message function, so you can send messages to the render script or like the rendering system. You can even add a function for hot reloading, so if you want to play around and like update the rendering in runtime while you...
But does it get bundled with the engine, or do you have to create? So for example, this code, did you create this code?
This code I created, or I copied actually the one that we ship with the editor or the engine from the start. So there is a default render script in the built-ins folder.
Default.
Yeah, default. In the built-ins folder, you have a folder called render, and this is the render file and the render script that is being used if you don't do your own rendering.
Okay, so if you want to do your own rendering, you copy the code from default render to custom render and then specify the new script.
Yeah, so I just copied this one out, put it in my own folder here, and what you need to remember is that you need to specify the new file that you created or that you copied here in the game projects file.
So what can we do in a custom render script?
So the render script, it's, as I said, is pretty much, it's Lua. It's like the other scripts that you have for game objects, but you have a special module called render here, which has a couple of functions that is specific for rendering. And our render script, it defines how to render your game. Okay. So first of all, you specify what like tags you want to render, and tags is something that you specify in a material. A material is something you, for example, put on a sprite. Okay.
If we can say an example of a sprite.
Yeah, so let's look in our main collection here. I have a game object which has two sprites.
Good.
And one of the sprites here has a material, the default sprite material. So let's look at that one. It has a couple of shaders, it has a name, it has some constants and stuff like that. We don't need to worry about that yet. But it also has a field here called tags, and it is called tile. So if we go back to the render script, you can see that the first line in it.
Tile. I see tile.
So I specify the predicate, which is like catching which tags I want to render. So I say I want to have tile here. Store it in this variable. And just to jump ahead, let's look at the update function. So this function is the one that will run each frame, right? I've refactored a bit here, so let's take a look at draw world. It's a bit of setup in the beginning here, so ignore that for now and just look at draw world. A bit more setup, camera stuff. But down here you see the function called render.draw, and I pass in the variable I created earlier, and this tells Defold the runtime that at this point, I want to render everything that has the tag tile. So everything, if I had more sprites, or maybe a spine scene or anything like that, and if that material had the tag tile, it will be rendered in this instant.
Okay.
And a couple of other things. So I skimmed over a bit of initialization code here. So there are a couple of functions that you usually call each frame. For example, you want to clear the screen.
Right.
I want to clear it to a color. They should also stored in a variable here. This means that once this is called, the whole screen is set to a specific color, right? This is very fundamental in rendering code, and people will recognize this.
While we're on that, do we have a good documentation on the render?
Yes, we have. Do you want me to show it? API reference. And render. At the very top here we have render, which is one of the systems. And these are a lot of functions.
Lots of stuff to do and to learn.
Yeah, a lot of things to play with. Okay, let's go back here.
Yeah. So good. Render is in the docs. Exactly. There's a lot to read and to grasp, but let's see what we can do in this example.
From the very top down, looking at a render script, you have the init function that will run once the engine starts, and you have the update function which will run every frame. Okay, let's see here. Let's take a look at the draw world, maybe. Did I put it? So these things I jumped over in the beginning. It's in Defold we have a component called camera, right? But it's actually not used in the default render script. You could use it if you want, set the component to a game object and set the camera component to the active camera, and it will the component will actually send updates to the render script telling, oh, so this is my new view matrix and this is my new projection matrix. In this example, I'm not using the camera component, so I'm setting up my own camera here. I'm going to set the view matrix to identity matrix, so it's going to be centered in Origo, like the center of the screen. I'm setting up orthographic projection. You can use a perspective projection, which is more typically used in 3D games, right? But this is a 2D example, so I'm going to use an orthographic camera. And this is everything you need to do to just get up a camera for rendering, right? A couple of 2 function calls, calculating what are the dimensions and stuff like that. So this is the fundamentals of a render script, right? So you need to say which tags or materials and stuff I want to render, and when I want to render them. I need to set up a camera so it's actually displayed correctly on the screen, right?
But effects.
Yeah.
Effects.
So
I can't wait till the effects.
So now let's jump ahead and do something fun. Let's see how it looks without post effects, right? So I'm going to run this. I have my sprites. I have another animated sprite in the background, the flames, right?
Yeah, a bit of greening today. Yeah. We still have summer in Sweden, so
fire hazard. Now I want to. So this is actually what's happening when I run the function draw world. It's the sprites, the animated sprite, and the default logo. I want to take the result of this, render it to a texture, so actually can do some post-processing on that texture. So how do I do this? I've actually, in this example, I put my actually the world drawing into a function, which is good to have when you want to do stuff like that. And I have created a draw post process function that I'll go through a bit later. And if we go back to the update function here, you can see I have a little if statement here. If post process is enabled, I'll actually draw the world first, and then I'll do the draw post process. And as you can see here, I'm going to pass in a little variable PPRT, post-process render target, or render texture if you want to call it that. But let's wait a minute and see what actually this variable is. I'm gonna do like this maybe. In my init function here, I'm gonna call a function that I created called recreate render target. In my init function, I want to create it, but I also, when I resize the window, I want to update the resolution of the texture I'm rendering to fit the new screen window resolution. So that's why I actually put it in a function here, and so I can recall it later on. And the function works like this. So if I already have a render target, I'm going to delete the old one. There is a bit different ways to do it, but I like to do it in this way. And as you see at the very bottom here, I call render.render target. It takes an ID or a name, but it also takes a table of arguments. And I specified them here. The parameters of the table you pass to the render target function is, let's say, you need to say it for the color part of the render target, I want these arguments, and for the depth target, I want these options. It looks pretty the same in this case. I have a width, a height, like the resolution of the render target, and for in this example, I have both the color and depth. They have the same resolution. I also need to specify what format the texture needs to be, or I want it to be. I'm going to use RGBA for the color and format depth for the depth target, depth texture. And it's simple like that, just setting up a render target in Defold. So when I call this function, I'll get back a render target that I'll put in this variable here.
Yep, makes sense.
We'll go back to the update function. As you can see here, the draw world, the same that we used without post-process before, but now I'm also passing in the PPRT variable here. So let's look at how it's used. So draw world, my function, it takes an argument called toRT, which is what render target am I going to render to, right? So the first if statement checks are we rendering to a render target? And if we are rendering to a render target, we need to enable that render target. This means that everything I do from this step on will actually render to that target. And at the bottom here, you see that when I'm done with rendering my world, I'm going to disable it again. So I'm going to enable the render target. I'm going to clear the render target, which means I'm going to fill the texture with some color and the depth with some values. And just as before, I'm going to set up a camera, just as before, right? Set up some render states, like do I want depth testing and stuff like that. And then I'm going to draw. But instead of drawing to the back buffer, this is going to be placed in the texture. Okay. So let's see if we comment out this function for now, like the function that actually draws the result to the screen. Let's see how it looks. It doesn't work. Oh, I need to. So now I'm enabling rendering to texture. This means that the thing that we saw before, which is the draw world, is actually being drawn to a texture, but the texture isn't being drawn to the screen yet. So now we need to take care of that. And how do we do that? So in the render scripts, you are actually able to take the result of a render target, bind it as a texture before you render maybe a full screen Sprite or anything like that. You can even render stuff to a texture and use it on multiple sprites afterwards. Maybe you'll want to have a TV screen in your game, and you have something that you render to a texture and put that texture on the TV screen, right? So how do I render it to the result? Let's take a look at the main collection again. I've created a game object that I call post process, which has a model. I could have used a sprite in this case, but we need something that will, with a special material that we can control when to render, right? And that will fit the whole screen.
Yes, but what is a model?
A model is a 3D model. In this case, I've just created a simple quad. Yeah. So it has at the very bottom corner it has like -1,
yeah.
and at the top it has 1, 1. It's a very small quad.
Right. So just so I understand, maybe somebody there.
Yeah.
What is, in this case, what is the difference of drawing a quad and just a sprite? Like, why do you prefer a quad instead of a sprite?
I think it just in my case, I've always used a quad. I like to have that control, but you could have used a sprite. You need to make sure that the sprite is like 1 pixel, or you could make sure that the sprite is actually the size of the screen. But since we're resizing the window, maybe you would need to take control.
You just have a bit more control with the quad, and it's just nicer to work with.
A sprite would have worked, but
fine by me.
It's old code, so yeah. We can actually zoom in and see that it's a very small quad, right?
Yeah. That's a very small quad.
And if we take a look at the model here, okay, yeah, all right. It actually has some texture set. It's not very important, but what is important is that it has a material, right?
Yep.
And as we saw earlier, materials have tags. So let's look at what tag this has. This material I've named to FS quad, so like full screen quad.
Yep.
And let's go back to the render script. Oops. Did I actually write something? All right. At the top here, that we previously defined the tile that we wanted to render later on. We also create FS quad pred. So we take all the materials that has tag FS quad, and we want to use it later on, right? And in my draw post process function here, it's just as before when we used tile, right? I'm going to use render.draw fs quad pred. So when this function is called, it will render the full screen quad, but it's very small, so I need to set up a camera so it actually fits the quad perfectly. And this is done in the beginning here. So I set the projection, orthographic, lower left corner, and stuff like that. So you see it's actually -1, like left side, and so I set up the camera, but first of all I actually want to enable the texture that we previously rendered to, right? And just as we did with draw world, I pass in the PPRT here. Let's comment this back. It's being passed in here, so I'm going to do draw post process. I'm getting the render target here. I'm enabling the texture from the render target, and I want to use the color texture, which is in the render target. Right. If we ignore these parts for now, we can actually, ignore these parts for now. And we see that I'm enabling a material, and then I'm drawing. Let's take a look at enable material. So a render script is attached to a render file. This is the one that I specified in the game project. And the render file you can specify a couple of materials that you actually want to change or use in the render script. So for example, I've defined the grayscale, pointed it out to a material on disk here. If we go look in the render script again, I'm going to do render enable material. I'm going to pass in a variable here, pp material. So this means that I can change in runtime which material the post process actually is using. And before we exit this function, we want to disable the texture and disable material, so it isn't used later on in rendering. So let's save here and run again. See if it works. So I'm enabling the post process. These are just some GUI stuff that for easier debugging. And now it's actually using the grayscale one. I can check this one and it will invert all the colors. And this will animate the texture coordinates.
Of the quad, right?
Yeah, exactly.
Yeah, you couldn't have really done this with the sprite, right? Can you animate sprite vertices? But this is off topic anyway.
Yeah, I mean, it's actually when you're using the texture, which is the output from the render target, we can actually take a look at one of the materials just to better explain it. Let's take a look at the animate chords, right? It's this one. Oh, maybe I can't jump. Effect anim chords. Effect anim chords material. It has two shaders. So if we take a look at the pixel shader or fragment shader here, it will get the texture. This is the texture that will be set when I do the function render.enable texture. So this will be passed along here to text 0. And before we sample, when we sample text 0, we're going to use UV 0, which is something that I animate. Like I'm gonna use the regular input I get for the texture core, so it's gonna if I hadn't done this. Oh, that's not Lua. Nothing happens, right? But in my shader I can actually change the stuff that's going in. So I think it would have worked with a sprite as well.
Oh, I see.
I mean, it's just
right.
Yeah.
Since it's in the shader.
Yeah.
Okay. Okay.
So this is the very basic, like how to do a post process, right? You render to a texture, you use that texture, you, like enable it, and then you draw to screen. You could have used a sprite, but I used a full screen quad in this case. But just rendering a texture back to the screen isn't very fun, right? As you can see in these examples, like the different materials, I would probably want to send in like a value to the shader
to play with.
Yeah, exactly. And this is what actually is done here. The UV, like the texture coordinates, they're actually being modified a bit by something, by a variable a here, which comes from the anim.y. So what is anim.y? Anim is a uniform. If you've done any shader or material stuff before, you probably know what a uniform is, but it's a way to pass value from the runtime to the actual shader.
And this is OpenGL, that's how it looks to my eye.
Yeah, so this is actually GLSL. All the shaders in Defold is GLSL currently. I just want to go through how to do it very simple, like just passing along a value. So in this example, I'm going to pass an animation value, like just a float that keeps on going from 0 to infinity, essentially, and update each frame. There are a couple of ways to do it. You can do it through a game object script. You can say, on this material or on this sprite, set this constant to a specific value. In my render script, which is here, there's another method as well. So the render.draw function that we saw earlier, where we're passing the predicate or the tag, we can also pass in a list of constants.
That's a table.
It's actually It could have been a table, but it isn't. It isn't. It's actually a special value or structure in Defold, which you create by calling the render.constantBuffer.
Okay, fine.
And then I'll get back. It actually looks a bit like a table, so I can do like constants, and I can set the prop or the .anim.
Right.
And the anim here is something that you will recognize from the shader I showed earlier. It was the name of the uniform, right?
So these are JLSL objects then?
Essentially, you could say like that, yeah. So what I'm doing here is just setting anim to a vector 4. The x component is the time, like the dt time, and the self.anim is the time that just goes from 0 and update its frame increases, right? And as you saw, I'm setting this in the y component here. Let's take a look at the shader again. Anim.y is actually what the time value, right?
Yep, okay. So we pass the parameters from the render script to the shader now.
Yes. One important thing to remember when you're doing stuff like this, like passing values to the shader, is you need to specify them also in the material.
All right.
Yeah.
Yes.
So I need to say like the anim here is a user type user constant. That is, it's up to me to actually specify this to the shader or to the material. This is just another uniform, probably. Yeah, prop here. Right. Okay.
Good. So we've passed the values to the shader. We've modified these values.
Yes.
In the shader.
Yeah.
And then we draw that.
Yeah. So it's actually passed along as an argument to the draw function here. I guess I could have. This is how it usually looks like. Render.draw and the tags I want to draw, but I can also add the constants here, right?
Okay, fine. So we've explored the whole thing pretty much.
Yeah. It's very
now I'm thinking what would be the next steps for whoever watches this video.
Yeah.
What should they? Probably they should play with the tutorial.
Yes.
With the shader toy tutorial.
Yeah.
With the shader toy tutorial. Right.
Yeah. And this is also available, this project, if you want to like play around with the post effects and maybe start with this and copy something from shader toy, like doing some mishmash of post process from shader toy.
I'll put the links below. So after you like this video, you can click on the links below.
Yeah.
And after you subscribe to the channel, but you should be subscribed, so this is fine. Yeah. My last question before we finish today is, what if you wanna apply a post effect to a set of game objects, to a collection? What should you think about tags, about grouping that, or about how do you like the camera view, maybe viewport, or what should you think about? We're not gonna explore this now because of time limits, but
I mean, if you want to do like effects on specific sprites, for example, I think the easiest, at least way to start, is copy the sprite material out to your own folder here and modify it and play around with that. And set that material on your sprites that you want to have effects on.
It makes sense. Yeah. One material for those objects that you want to apply post effect to. Okay, fine.
And those could have like a specific tag if you want to render them in a specific step in your render target, a render script. I guess another way is to maybe not even change the shader of those sprites. You can have just change the tag and make sure they render in a specific step to a render target and do some magic with that result just for those sprites.
Yeah,
that's another way.
Okay, makes sense to me.
Yeah.
So thank Sven for exploring this.
Thank you.
And thank you for watching the video. And we'll be back as soon as you tell us what to film the video about next. Make sense?
Yes.
See you soon.
Bye. Sorry. Yeah.
That's fine.
Yeah, I wasn't with you. So